Hi everyone. Today I'm going to show you something really cool, an AI powered system that converts natural language questions into SQL queries using knowledge graph. This is not just another chatbot. It's a sophisticated pipeline that understands database schemas and generates accurate SQL automatically. Let me demonstrate this with a real example. I will ask, what is the alphabetically ordered list of all distinct medicines? Watch what happens here. The system is now processing my question through a multi-step AI pipeline. First, it, it's retrieving context from the knowledge graph. This is where it searches for relevant database schema elements. Then it's doing vector similarity node search to find semantically similar nodes. Then it builds a context graph from the retrieved nodes using breadth first search algorithm. The AI agent is now pruning and standardizing this context. Finally, it's generating the SQL query and executing it. And here we have it. The system generated a perfect SQL query that selects distinct medications ordered alphabetically, and we can see the results right here. This is all happening automatically, no manual SQL writing required. Now let me show you how this happens under the hood. We have this project with several key components. First, we have the agents directory. These contains our AI agents, the pruning agent that filters and standardize the retrieved context, and the generation agent that creates the SQL queries. Both of them uses Google's Gemini AI model. Here are the system prompts that guide these agents. The pruning agent removes the redundant information and organizes the context, while the generation agent maps the question to relevant tables and generates the valid SQL query. Now, the heart of the system is the knowledge graph construction. Let me show you how we have built this. First, the connect.py files handles the connection to the Neo4j Aura database, which is hosted on a cloud platform. We are using Neo4j because it's perfect for representing database schemas as interconnected nodes. Now we take a database schema and convert it into a knowledge graph. We create nodes for databases, tables, and columns, then establish relation between them. Foreign key become connections between columns, and we track primary keys too. Now we generate embeddings for all the schema nodes using OpenAI's embedding model. This allows us to do semantic search. When you ask about medications, the system can find the drugs table even if the exact word doesn't match. Now coming to the main.py file to show you the main workflow. This is where everything comes together. The process starts with the user question. First, we search the knowledge graph using the vector node similarity to find the relevant nodes. Then we retrieve a subgraph around these elements using BFS algorithm. This gives us the context that we need. We pass this context to our pruning agent, which filters and standardizes it. Then the generation agent takes this clean context and generates the SQL query. Finally, we execute the query and return the results. Notice how we track each step with status update. This is what powerful, the beautiful pipeline visualization you saw in the demo. Now, this is not just a technical demo. This is a system that can be deployed in real organization. It has the combination of knowledge graphs, vector search, AI agents, and it creates a powerful solution for natural language database querying. What we have built here is the complete NL to SQL system that combines the power of knowledge graph with the modern AI. It's not just about generating SQL, it's about understanding database schemas, finding the relevant context, and creating accurate queries automatically and showing the answers to the user. Thanks for watching.